everybody. Good morning. I would like to start a chapter on speed, distance, and time. Speed, distance, and time. I'll start with the basics. Speed is defined as distance by time. So, in order to find the distance, you'll need to have the information of distance and time. So, there is one more easy method to remember this. You must have already heard that people will say you can always equate the units with respect to the definition, right? So, unit of speed is kilometer per hour, as distance unit is kilometer and time unit is hour. This is basic units. So you may be even asked sometimes how to convert to meter per hour. So 1 kilometer is 1000 meter. I think my previous videos have already explained what are the equal units for all basic units asked in the exams. Similarly, 1 hour is 60 minutes, which again equates to 60 seconds. So 1 hour is equal to 60 into 60 seconds. More than this, if you have to convert kilometer per hour to meter per second, you must have always had the direct numbers, but let me show you how it is converted. So for converting kilometer per hour to meter per second, as I've already shown you what are the values into it. So 1 kilometer multiplied by 1000 will give you meters, and 1 hour multiplied by 60 into 60, that is minutes, and minutes to seconds will give you seconds. So this would directly convert into meter per second. So 1000 by 3600 will directly give you meter per second, from 1 kilometer per hour to meter per second. So if you have example, if you say you have 18 kilometer per hour, what would be the value in seconds? Okay, let me make this shortcut. So if you're going to cancel these values, it would be 10 by 36, which will equate to 5 by 18 meter per second. How it is 5 by 18? Just cancelling it. 2 5s are 10 and 2 18s are 36. So in case if you are given a value of 18 kilometer per hour, how will you convert into seconds? You have to directly multiply it by 5 by 18, which should give it to you 5 meter per second. This is very basics. If you know this and you are well versed in this, you can actually solve this any kind of distance and time questions very easily. So this is a very basic formula. Speed is equal to distance by time, and in order to get get the right answer, you should always remember that unit should be uniform. That is, if you're going to solve the answer using kilometers, all the units that you are going to do the process or do the calculation should be in kilometers. If it is in meters, it has to be in meters. Similarly with time too. If it is in hour, keep all the values or all the units in hour, or initially convert it and then start doing it. Don't think that you can do it on the process. Generally we do mistake while we think that we will convert it doing the calculations or while solving, and we often do error in it. So there's another formula for it. Okay, based on this basic formula, let's try to solve a question, because there are many other formulas related with it, like speed and ratios. Okay, let me do it for speed, and how a speed is related to time, because um, speed is not directly proportional, it is indirectly proportional to time, 1 by t. In case if you are going to compare two speed vehicle of two speed, then you can always use the speed formula and time formula in the reverse ratios. I'll tell you how. So example, let's consider speed of ambulance and to the speed of say bike. So the speed of ambulance to bike, so let it be speed of A, speed of B. So the ratio would be speed of ambulance is generally faster, right? So let this be 100 kilometer per hour, and let the speed of bike be say 10 kilometer per hour. So we can see it and can determine that speed of ambulance is more than speed of bike. So a distance covered by ambulance would be faster for the same time, and distance covered by bike would be lesser compared to the ambulance speed. So how is this related to time, and how we shouldn't confuse when the ratios are involved? So speed of say ambulance, and considering both are going to um, cover the same distance, but speed and time would be different for each case. Similarly, speed of bike for the same distance, time would be different, right? So in order to solve the question and find that speed of ambulance is to speed of bike, when we equate it, the the time of bike should be equated with ambulance, and the time of ambulance should be equated with bike. How? So let's consider it as mm, okay, there's one more shortcut before I would like to solve this question. So when randomly, roughly, if speed is given as 100 kilometer per hour, so it means that it means that for 1 hour a vehicle could travel 100 kilometer distance, that is it could cover 100 kilometer distance. Roughly, when questions are asked, if in case they say how much distance can it cover in half an hour, that is in 30 minutes, you can roughly directly calculate it to 50 kilometer. And 15 minutes, again another half, 25 kilometer. So this is rough calculation for which you don't need any formula. Directly put your logic into it and check that for 1 hour, if it could cover 100 kilometers, for 15 minutes it could directly cover 25 kilometers. This is blind logic. Okay. Similarly, you can do it for 10 kilometer with respect to ratios. And to trick you, they might say they will not directly give you 15 minutes. They might give it in seconds. Like for 30 minutes, they would say 30 minutes, they would say 60, give seconds. How much will it cover in 1800 second time? So directly roughly calculate it for how much it can cover in 30 minutes and then directly say the answer 50 kilometer. Okay, come back to this problem about speed. In this, ratio of time for with respect to speed of vehicle. So ratio of time is, you can directly say speed, I said, so d by time of ambulance is to d by time of bike. When you equate it, dd would get cancelled, so speed of A is to speed of B vehicle will be equal to time of B vehicle is to time of A vehicle. This is very important concept when we have ratios between time and speed. This is how this formula is derived, that dd would get cancelled for the same distance. When you are going to calculate for ratio of speed for two vehicles, we have to interchange the time of the vehicles in order to solve the question. So let's try to solve one problem. Today I am taking reference from R.S. Agarwal book. So there is this question, if you could see. Yeah. So there's a question given. While covering a distance of 24 kilometers, a man noticed that after walking for 1 hour and 40 minutes, the distance covered by him was 5 by 7 of the remaining distance. What was his speed in meters per second? So before explaining the question, I would like to say that many of us do mistake, not because we couldn't solve the question, it's because we didn't understand the question. Once we understand the question, it is very easy to solve, as it's just processing it, nothing else. But give enough time and solve enough problem so that you don't misunderstand the question. So in this question, let me keep it. So in this question, it's saying that while covering a distance of 24 kilometers, a man noticed that after walking for 1 hour 40 minutes. So consider a man is covering 24-kilometer distance. So this distance is 24 kilometer. So it's saying that while covering a distance of 24 kilometers, a man noticed that after walking for 1 hour and 40 minutes. So he actually walked for 1 hour and 40 minutes, which should be actually 60 minutes and 40 minutes. 1 hour is equal to 60 minutes. So 60 plus 40, we would get 100 minutes. The distance covered by him was 5 by 7 of the remaining distance. Here is a twist, and try to get the statement. The distance covered by him was 5 by 7 of the remaining distance. There was no reference to the remaining distance previously from the beginning of the question. And suddenly they are saying that of the remaining distance. So let's assume first what is the remaining distance. Then we could understand what the question is saying. If the remaining distance is taken as x, so he covered certain distance, we don't know how much he has covered, but the question is referring it as the distance covered by him, that is the distance covered by him from the beginning of the distance. The distance covered by him was 5 by 7 of the remaining distance. Say if this is x, then the distance covered would be 5 by 7 of x. This is what the question means. If you could understand and if you could interpret the question properly, you will get this formula easily. So then once you get this formula that the remaining distance is x, and so the distance covered by him is 5 by 7 of x, what was his speed in meter per second? So what is the question? What are they trying to find out? We have to find the speed of this man in meter per second. Okay, so meter per second is important. How are we going to solve this problem? So in order to solve this problem, we'll have to find x, because only if you could find x, speed is distance by time. Only if you could find distance, that is x, we could then find what is 5 by 7 of x, which he has covered, and we already know what is the time, so we can directly interpret it. Okay, so how are we going to solve it? See, speed is equal to distance by time. How much is the distance? Distance is x, and no, distance is 5 by 7 of x. We are going to take with respect to his distance covered and not the remaining distance. This is his remaining distance. So in order to find the speed, we are going to find how much distance he covered with respect to how much time he took. Time is already given, 100 minutes, and what is the distance? Distance is 5 by 7 of x. Now we'll have to find x. So in order to find x, we know from the question given 24 kilometer is equal to x plus 5 by 7 of x. X is the remaining distance, 5 by 7 x is the covered distance, which should give to be 7x plus 5x by 7. 24 into 7 equal to 12x. 12 2s are 24. So 14 is equal to x. So x is 14 kilometer. Remember, all we are doing is just finding kilometers and nothing is involved. That is, everything is with respect to only distance. We are not taking speed as an example. We are not taking time as an reference. It is only the distance with respect to just equating the given information. 24 kilometers is equal to 5 by 7 x plus x. So we found that x is 14 kilometer. Remember, this is in kilometers still. So the question says they need speed, right? Now that we know that this is 14 kilometer, we can find what is the distance covered, that is 5 by 7 of x, which is 5 by 7 of 14 kilometer, 10 kilometer. So distance covered by him is 10 kilometer. Now what? Now we know how much distance he covered, we know what is the time, so it is time to find the speed. Speed is 10 kilometer by 100 minutes. Remember, I keep writing the units along with it so that we shouldn't miss the unit. So speed is equal to 10 by 100, and we want this 10 kilometer by 100 meter in meter per second. So as I told you, 10 kilometer into 1000 will give you in meters, and 100 minutes into 60 would give it in seconds. If you're going to cancel it, you will end up having 10 by 6 meter per second. For 10 by 6 meter per second, we can further reduce it to 5 by 3 meter per second. So in order to again put it in mole fraction, you can say it as 1 2 by 3 meter per second. Usually this kind of fraction will not be asked. This would be the final answer, but still, just to show how this happened, how this is derived, and this is the standard formula followed in Agarwal. I'm just writing it. Thank you.